Hey guys, it's Mr. Young, and today we're going to talk about section 7.4 in your textbook, which is similarity in right triangles. We've been talking about similarity in polygons, a lot of similar triangles, a lot of similar polygons last week. This week we're going to extend that into a special similarity case for right triangles. So we get this scary definition here of our theorem. It says, if triangle ABC is a right triangle, and it tells us where the right angle is, and then it talks about an altitude. That's not a word that we've defined yet. The altitude here is CD, altitude to the hypotenuse. So our hypotenuse is AB over here. Altitude just means it's making a right angle to it. Some of you will recognize the word altitude as meaning height. So the right angle here ensures that this is a measurement of height because it goes from the bottom of the figure straight up to the top. So if you just remember altitude is height, you'd be fine. But we're not really going to use the word altitude. The book uses it here. We're just going to define this in terms of whenever we have a picture, and when that picture looks like this. So we get a little right triangle there, and then we have a piece extending from our right angle in our large right triangle to its hypotenuse and making another right angle. So what's going to end up happening here is we're going to get three completely separate, distinct triangles. Whoops, let's try that line again. Let's try all those lines again. So I'm going to give us a right triangle with another line cutting that into three right triangles. All right, and now what we're going to do is we're going to separate this into a couple of different triangles. But first we want to label it. So I'm going to label every side of this thing, A, B, C, D, and E. So I've got ABC here, and now notice on this last side, I'm going to label these two pieces separately, D and E, because those are two separate lengths, and that's going to become important pretty soon. So the first thing I'm going to do is redraw my triangle as three separate triangles. Let's make a straighter line than that, though. So I'm going to draw three triangles. And I'm going to label them S for small, M for medium, and L for large. And I'm going to draw all three of them in the exact same orientation. So every time I draw a triangle in section 7.4, it's going to be a right triangle that looks exactly like this. Now I need to label all of those triangles. You should be doing this along with me on your paper as part of your notes. So if you haven't been taking notes yet, go ahead and pause and get caught up. You want to draw this triangle, label A, B, C, D, E, make three new triangles, small, medium, and large. Now I'm going to label them. So I'm going to start with actually the most difficult one, our big triangle, the large triangle. You always want to orient yourself with the right angle. So we're basically just spinning this triangle. So the right angle is drawn here, and you always, from your right angle, want to think about your small side and your longer side. So if I look at my big right triangle, my small side is A, my longer side is B. So I'm going to go ahead and label those, A and B. And then the trickier part here is labeling your long side. The long side is not D, it's not E, it's actually D plus E. So if I look at this picture down here again, if D were, say, 3 and E were 8, this whole length would be 3 plus 8, or 11. So sometimes you'll get into a messy situation where one will be an X and one will be a number, but oftentimes they'll both be numbers and you just need to add them together. So I've got my large triangle labeled. Now I'm going to focus on my medium triangle. That's here, where the small one is on this side, on the left. So the medium triangle in this picture is on the right. And if you look at it, we actually don't need to do anything to label it in terms of rotating it. It's already in the exact orientation that we want. So I'm just going to translate that CBE over because we have our right angle right there and it looks perfect. Now we move on to our small triangle. Again, if you need to, go ahead and pause, rewind, ask your neighbor a question. We're going to go to the small triangle. So the small triangle's here on the left. The shortest side of that is D. So I'm going to bring D over here to the short side. The medium side of the small triangle is C. So I'm going to label that C. And the hypotenuse, remember back to right triangles, the hypotenuse is across from your right angle. The hypotenuse here is A. So now I've taken my starter triangle and I've created 3 separate pictures from there: the small triangle, the medium triangle, and the large triangle. So now let's head back to our theorem. The theorem states that when you get a picture that looks like this, like we have down here, the big black triangle, then it's going to create 3 triangles, the small, medium, and large, and they are all similar to each other. So down in my picture here, I can say that this triangle is similar to this one is similar to this one is similar to this one. All 3 are similar to each other. Okay, so now we'll get to our first problem that we're going to do. Notice this is problem 3 in your textbook, so we're in section 7.4, like I said at the beginning. We're working on problem 3, and see how problem 3 has that sort of orange, lightly tinted box around it? That's the color your textbook uses to indicate a hyperlink. So you can click on problem 3 in your textbook and watch a video, a separate video from this one, on how they're going to solve it. But they solve it a little differently from how we do. So let's watch this video. We have our triangle. Notice the triangle looks similar to what we were just talking about. It's got that larger right triangle and then another right angle that kind of cuts that triangle in half along that side. So what we're going to do, same as before, is draw 3 triangles. Every problem I see you guys do in your notebooks, this should be the second set of 3 triangles you're drawing, because you should have drawn the last one with me. And you're going to have to submit your notes at the end of the block. So if you have not been taking notes and drawing those, you might want to go back, grab your notebook, and take some notes. So I'm going to have my large, my medium, and my small triangles all set up and ready to go. And now I need to label them. So let me get, we'll switch up the laser pointer colors here. My small triangle, I'll start with that one. So here's my small, this little guy here. The right angle's here, which makes this side my small side, this side my longer side. So my small side, is 4. My longer side is y, and the hypotenuse in that triangle is x. So if you need to, go ahead and pause. Take a minute, look at that triangle. If it's too small in the video, go ahead and look at it in your textbook, copy it down into your notebook, whatever you need to do. I'm not here today to support you guys. Then we'll move on to the medium triangle. So we'll find our medium triangle, that's this side. Find the small side of the medium triangle. Small side is y, the longer side is 12. The hypotenuse is unknown. So let's fill those things in. The small side is y, the longer side is 12. The hypotenuse we just don't know. And that's fine, it just means it's not something we're going to be able to use to solve this problem. And now we'll go to our big triangle. So when we look at the big triangle, the short side is x. Here, the long side is the one that's unknown. And we need to pull these two numbers together up here, 4 and 12, to give us 16 for the hypotenuse. So now we should have our three triangles all set up, everything nice and neat and labeled, and we're ready to go. The first thing we really need to do is look at these triangles and try to determine, of these three different triangles, what kind of pairs can we use to sort of set up an equation. So what we really want to do here is, let's think about x first. So we have an x here, we have an x here. So if we kind of go ahead and let's highlight those sides. Let's get a larger highlighter than that. Got an x here and an x here. So if we want to solve for x, we need to be using these two triangles, because those are the only two that have x in it. Also notice that in those two triangles, there is a side that we do not know. We don't know that side. Oh, maybe I shouldn't call it x, huh? Let's just kind of get rid of the line. We don't know that side, so it can't help us in this problem. But there are sides that we do know, and we are going to need to use them to solve here. So we're talking about similarity again. All three of these triangles are similar to each other, which means we can set up proportions like we did before of corresponding sides. So here I'm going to set up a proportion. I like to always start with my small. So let's go with our 4 here. The small triangle has a side of 4, and we're setting up a proportion between our small triangle and our large triangle. So 4 is to x because they're in the same spot. That's why we spent so much time redrawing these three triangles and putting everything where it needs to be. 4 is to x, then we want to do the other side. So the other side that we know, be careful here, don't fall into the trap of using this y. There are two things wrong with that. If you use this y, it's going to give you an equation with an x and a y in it. We want to avoid that at all costs. But also, you're going to get another unknown because we don't know this side that it corresponds to. So in this problem, you do not want to touch that y. So we're going to use our x here, and our x corresponds to the 16. Those are both the hypotenuse of their respective triangles. Now we get an equation that we can solve. It does look a little bit different than the ones we've been solving, but let's cross multiply. X times x, this is where it gets different, is going to give us x squared. It's nothing you haven't seen before, it's just something we haven't seen with similarity before. And 4 times 16 is going to give us 64. So take a second and pause if you like and try to solve that. Think about, how do we solve that? What is an x squared? How do we simplify that and get it down to just x? So the way we get rid of the square is by taking the square root. So we'll get the square root of x squared is x. And if we take the square root of x squared, whatever you do to one side of an equation, you have to do to the other side. The square root of 64 would be 8. Now that we know that, we can go up here to where we have these x's, and we can plug 8 in. Notice we had 2 x's. So now we've just got a little bit more in the problem to use to our advantage. But we're not done yet. We have to solve for y. So solving for y, let's try and find the spots where y is actually used. Here we've got a y. And here we've got a y. So it looks like we're not going to be using our big triangle anymore. We're going to be using our two smaller triangles, the small and the medium. So using the small and the medium triangles, and again, note that there's a side we don't know, which means we're not going to use this big long side, even though we just figured out in the small triangle that it has a length of 8. We're not going to use that quite yet. So we can set up an equation. Again, I like to start with the smaller triangle. So 4 is to y as, back to the small triangle, y is to 12. Cross multiply again. Y squared equals 4 times 12, or 48. When we go to solve, we'll take the square root of both sides, and y will equal the square root of 48. So the square root of 48 is not really a perfect square. It's not one you should know off the top of your head. We do know, I'll go up in the top corner. Whoops, I moved stuff. Didn't want to do that. I'll go up in the top corner here. We do know the square root of 49 is 7. So the square root of 48 should be very close to 7. So if you play with your calculator, if you aren't already aware of how to do a square root, you should find that the square root, I shouldn't say equal to, I should say is approximately equal to 6.93. Just under 7, which we suspected because of the square root of 49 being so close. So make sure you've got this one in your notes. Again, it's something I'm going to be looking for. When I see this problem in there, you should have all of this work that we did, including especially these 3 triangles, the small, medium, and the large. I want to see all 3 of those. You need to be writing those out. You have to show your work for these. It gets very complicated until you figure out the shortcut tricks. So for today, I still want to see 3 triangles for every problem. Okay guys, one more problem for us to do, but we're not going to do this one together. I want you guys to solve this one separately, and all I'm going to give you is the answer at the end. So let me just give you a little bit of a setup here. It's just like the last one. If you need to pause, go back, check your notes, do whatever, you've got plenty of time. You're going to copy this figure as is into your notebook. You're then going to draw the small, medium, and large triangles, being very careful to figure out which pieces go where. Set up your 2 proportions, one for x, one for y, and solve. Remember, I want to see your notes today. I need to see your notes today for you to receive credit. And this problem needs to be in there with 3 separate triangles. Get some help from a neighbor if you need to. But make sure now you take the time to pause and solve it. All I'm going to give you is the final answer. If all you have is the picture and the answer, you're not getting credit. So go ahead and pause now if you haven't already. Okay, it's time for some answers. So you should have that x equals 6 and y equals the square root of 20, which is approximately 4.5 when you round. Okay, I'd like you guys to copy all of this down. This is actually from your textbook, but four quick problems, numbers 3, 4, 5, and 6. They're from the exercises right at the end of section 7.4. And I'd like you to just go ahead, take this figure like we've been doing. So this set of right triangles here, the three of them, copy the figure down, then break it up into your three triangles, your small, medium, and your large, label everything, and then go ahead and fill these in. It should be really straightforward to find the two triangles that both have a G and an E in them. Only two of them will have the G and the E, so I'll give you guys a hint. For the GE one, you need to use the small and the medium triangle, because the large is just going to have D, F, and J in it. You can see that just going around the edge, D, F, and J. So copy those down. I'm not going to give you the answers to these today. We're going to go over them tomorrow. But go ahead and fill in each of these blanks. So G is to E, and I'm not pointing here at G and then this E, because that might make you think it's all in this same small triangle. But this is really talking about G from the small triangle and then E in this medium triangle, because it's the short side of this small triangle and it's the short side of this medium triangle. That's why we always draw three separate pictures before we begin, so that we're taking one from one triangle and one from another triangle. Okay guys, homework time. Your homework comes from the textbook, so if you'd rather do it out of the textbook, you may, instead of staring at this, instead of pausing the video and trying to do it that way. So in section 7.4, the exercises that come at the end, it's just these 7 problems, numbers 9, 10, 11, and then 18, 19, 20, and 21. Again, for 18, 19, 20, and 21, I need to see you draw a set of 3 triangles. For those of you that have been following along and you're getting it, it won't take you that long. You can probably easily finish before class is over and not have any homework. For the 3 at the top, notice I kept in here these additional links. See problem 1, you can't click on it here. You've got to be in your textbook, obviously. We didn't do a problem in this video like this. It's just writing similarity statements. So this is not an answer for any of them, but your answer would look something like, well, actually let me not try to write in a white pen. Should look like triangle ABC similar to triangle DEF, which is similar to triangle, let's just say LMN. So it's similarity statements relating the 3 triangles in each diagram. So you should have 3 things. It might be helpful for those, though it's not required, to draw out your small, medium, and large triangles.